to have Albin presentation. Albin is going to present a little introduction to Avalanche. For those who don't know Avalanche is a continual AI-powered library that's focused mainly on continual learning. And well, I don't want to spoiler Albin presentation, but whenever you're ready, please, Albin. And of course, if anyone have questions, you can raise your hand or please send the question via the Q&A, and we're happy to answer them at the end of the presentation. So please, Albin.
Sure. Yeah, thank you, Julio, for the introduction. So today, as the title mentions, I'm going to present you Avalanche, which is a continual learning library developed by members of ContinualAI. And yeah, so first of all, a quick intro about myself. I'm Albin Soutif, PhD student at the Computer Vision Center in Barcelona under the supervision of Joost, and my main focus is on continual learning. And I'm also an active contributor to Avalanche, which is why I'm giving this presentation. Okay, so just a quick recap about what we're going to do today in this hands-on session. So mainly it will be about presenting first inner workings of Avalanche. There's quite a lot of components to go through, so I prepared slides for that. And then I will just give a quick demo of how to use Avalanche by creating a plugin. I will explain you later what is a plugin, don't worry. And then I will present an application case, which is survey on online continual learning that we made with the help of Avalanche and with also in collaboration with a lot of maintainers of Avalanche. Okay, so first of all, what is Avalanche? So it's an open source library, a continual learning library, and its aim is to be an end-to-end continual learning library. And it's developed by it has been created by this ContinualAI Association, and it's maintained by a lot of amazing developers like Antonio, Lorenzo, Andrea, a lot of them. I cannot cite them all. And yeah, so it's an open source library. It has a MIT license. It has no more than 60 contributors. So I think that's quite a good news for the community that many people are contributing on the same code. And I think now it has gotten quite famous in the recent years, accumulating more than 1,500 GitHub stars. And we see that it's getting used more and more in research projects. And this is really a good news. Yeah, just for a list of research work that use Avalanche, I think more and more research work will be using the library, but this is just a quick list of works that have already been using the library successfully. And let's hope that this continues this way. Okay, so first of all, I'm gonna do a quick recap on why do I think we need Avalanche and why this is good news for the continual learning community. So first of all, I think it's nice that it's a shared code base, like open source code base for a lot of people who can use it, and there's more than 60 contributors for now. So what it means for all of these people that use the library is that they don't have to write that much boilerplate code than they needed to write before. Another point is that because a lot of people use this code, I think that it leads to a lot of errors reduction, because if you're just a PhD student working on your own code and you are the only one to use it, then maybe it will take months for you to spot a bug, and it could even affect the result of your papers or something. Whereas with a library, with many users like this, whenever there is a bug, it is spotted quickly and fixed by the maintainers and users through the GitHub. Okay, so another thing that I think is very powerful with this library is the ability to do very fast prototyping, and this is mainly due to the smart design of the library, let's say, which has this plugin system that I'm going to explain. And I think this is a very nice feature for researchers because, of course, we all want to try out our ideas as fast as possible. And then another point is, of course, the improved reproducibility and portability. So for this point, actually, I want to mention the existence of two other GitHub repositories. So one of them has already been presented by Vincenzo in the beginning of this unconference. And it's the Continual Baselines repository. And this repository aims at reproducing the exact results of the strategies implemented in Avalanche, so that people know that they can trust this code, because if we are able to reproduce the same results and the ones reported in the papers, then that means that we have reproduced the results, right? So, and I mentioned now this other repo that I'm going to present in the second part of the presentation, which is the application case. So the making of an online continual learning survey with the use of the library. And this repo is in the same vein than continual learning baselines, but instead of trying to replicate exactly the same results than the authors, it's trying to compare each method fairly under the same experimental setting. So that's more the goal of this repo. And yeah, the two last points will improve modularity. I think it's so Avalanche is not only trying to build one module of continual learning; it's really trying to cover the whole range of continual learning. So some parts of this library can be used in isolation. I'm thinking about especially the benchmark parts, and also the plugin system allows for a lot of modularity. And I think the last point I'm going to make is that the fact that we don't need to write any boilerplate code anymore means that we can focus on more important factors like improving the efficiency and scalability of the code. And I think this is a point that is in progress, and that will be getting better and better every month. Okay, so now let's do a quick tour of what is the general structure of the Avalanche library. So basically, there are these 5 components that are all very important to the making and benchmarking of a continual learning method. And I'm going to present quickly the features that Avalanche provides towards each of these components in the presentation. So we will start with the benchmark, then go through the training part, then go to the models, and then go to the logging and evaluation. But yeah, Avalanche is really implementing each of these components. So it can be quite intimidating in the beginning because there's a lot of things, but it's not that hard, honestly. Okay, first of all, for those of you who want to, let's say, code along during the presentation, or maybe try to use the library at the same time I'm explaining, you can install the Avalanche library very easily through these commands. But also I'm going to add that during the demos, I'm going to use the repo that we created for the online continual learning survey. And you will find the instruction on how to install this repo on the repo. I give it to you here. And yeah, I added a demo file that you will find on this repo as well. Okay, so first of all, I think a nice peek into the workings of Avalanche is first to see a minimal example. And that's why I'm showing this minimal example that runs replay method on split cipher 100, which is a very common continual learning dataset. And this is the kind of experiment that researchers in continual learning will run a lot. And this is just to show you that it does not take a lot of lines of code once you know how to use a library, so that you run this method. And we also can see that the different components that I presented to you before are here. So we first have the benchmark creation by the use of this split cipher 100 benchmark. Then we create the model by also changing the layer to a dynamic layer that I will present. Then we initiate the metrics, we create the loggers, we pack them up together, and we initiate the training strategy. And then we just have to do this loop, which is doing the whole training and evaluation. Okay, so now that you have this example in mind, I will present benchmarks and how to create a benchmark in Avalanche simply, and how to use them. So there's two main ways to create a benchmark in Avalanche. First of all, you have a lot of classical benchmarks that are already implemented, like all of the splits benchmark for MNIST, type-R10, and image nets. Also rotated, permuted, MNIST, this kind of domain incremental or kind of benchmark. And then also more advanced benchmark that have been introduced more recently in the literature, like Core 50, Stream 51, and etc. So this is one first way, and these benchmarks are very easy to call, as you see, have you seen in the minimal example. And another way is if you have your own dataset and you want to create your benchmark, or you want to do more fine-grained operation on the creation of benchmark, then you also have utilities that are meant for that, like a utility that is meant to split the benchmark in classes split, like to reproduce the class incremental setting, and also one for domain incremental. And if you have a custom dataset, or if you want to chain dataset into a continual learning setting, you can use this dataset benchmark and file this benchmark. And of course, for all of these points, this is true for the benchmark, but also for the other points that I'm going to present in this presentation, you can find a tutorial on the Avalanche website that is related to this. Okay, so then when we know how to create a benchmark, basically, so know how to use them, because this benchmark will return to you an object, which is called in Avalanche scenario. And what can you do with this object? So basically, this object, it will contain different streams, and the main ones are the training stream and the test stream, because they are almost always present in our experiments. But you can also add other kind of streams. I'm thinking about the validation stream, but also an out of distribution stream, for instance, or any kind of stream that you would like to evaluate on. Once you access this stream, you can access them like normal lists. You can also use slicing operation on them. And here I just presented a quick code snippet that basically is an operation that you do very often with these streams, because it's just the fact that you iterate on the training stream. So you get your training experience, and then you can access some attributes of this experience, like the classes that are in. And also you want to evaluate usually not only on one test experience, so by accessing the test UMT, but usually you want to evaluate on all experiences so far. So that's why you call this slicing with all experiences since so far. And then one last thing that I want to present on the benchmark side is the fact that this experience also, of course, contains a training dataset for this experience, this task. And these datasets are Avalanche datasets, which are wrappers around PyTorch datasets, and they come with nice functionalities like switching between the training and eval transforms, and also they have some subsampling and concatenation operation that are useful. I think that's it. Okay, just don't be confused in the next part of the presentation. Whenever I refer to an experience, this is the way we call the tasks, the continual learning tasks in Avalanche. And I think it's a choice that we made because it's not to be confounded with the multitask paradigm. So basically, you could imagine a training experience where you have different tasks in the same training experience, and you want to learn all these tasks at the same time, then it would be very confusing to call that a task. So that's why we call that an experience. But if you don't want to get confused about that, you can think that an experience is just like a task in continual learning. Okay, so now just a quick introduction, because it will be important for the next part of the presentation, on online benchmarks. So for those who don't know, an online benchmark is basically a more fine-grained definition of the tasks in continual learning, where usually a task would be a dataset of, let's say, 5,000 samples in the case of Cypher that you split in 10. But here in online learning, you would split this task in smaller tasks, which are at the mini batch level. So for instance, you would say that your mini batch is 10, and each experience will be of size 10, which is also the size of the training mini batch. And this is how this whole thing is treated in Avalanche. And so we have utils to create them through this online continual learning scenario. And basically how it's done is that just you iterate normally on the trade stream, but then you create your online continual learning scenario, which will split all of these experience into sub-experiences, and then you can train normally on this scenario. Okay, so now we are done with the benchmark. We can already do a lot of things. I want to present you what I think is the core part of Avalanche, and it's about strategy, like the training part of this library. So basically, I think one of the most interesting feature of Avalanche is the way they handle these training strategies. And the most important thing that you have to understand is that every strategy is following templates. And through this template, you can interact with the code of the strategy using plugins. So if you think about it, many continual learning methods actually use a very similar algorithm, but they just change some part of this algorithm, and that makes the specificity of the method. But most of these continual learning strategies, they will have to implement the SGD learning algorithm. And so that's why this template looks like this. Like basically, it's waiting for a training experiment, and when a training experiment comes, then you start training on it. So you have this before training epoch, and basically for each of these steps that the algorithm use, you have a callback that is called, and that will trigger the plugins. And you have a callback before every step and after every step, so that you can really insert code in every part of the algorithm. So maybe the best way to illustrate this is through an example. So for instance, we have this minimal version of the replay plugin. And what replay is doing is that it has to store samples after learning on an experience. And then during the training of the later experience, it has to use these stored samples into the training. So that's exactly what we see here. We use the callback after training experience that can interact with the strategy, as we see. And then we just store the whatever is inside the current dataset using this storage policy. So that we do after the training experience, and before training on an experience, we say that if the memory is not empty, then we combine the current datasets with the memory buffer, and that's it. There's no more code needed for using replay in Avalanche. Okay, here I give you another example that is an animation made by Hamed. And there is a very nice animation on how does EWC plugin work in Avalanche. And we could see that we'll see the algorithm calling the callback one by one and doing some operation only at some callbacks. So for instance, here it creates a training dataset, initialize the data loader. And we will see that, for instance, in the before backward, it will add a component to the loss, which corresponds to the EWC loss. So first we calculate the loss, then we add the component corresponding to the EWC loss, and also after training the experience, the EWC plugin will need to compute the new Fisher matrix for the computation of the next EWC loss, which is what it's doing. And then we loop like that for every experience. Okay. So now to finish the presentation on this training part, there is always a question that arises when starting Avalanche is, should I implement a plugin or a strategy? And I think I really want to emphasize that it's really advised to implement a plugin. Most of the time, it's really possible to do everything through the plugins because it can interact with the strategy in a lot of ways. No, implementing a strategy requires basically to copy the template and then inserting manually the code in between the calls to the callbacks, which feels a bit less interesting code-wise, because then this strategy cannot be combined directly with another strategy. But basically, I think whenever you think that your method can combine with another method, then it means it can be implemented with a plugin. Okay. So now, after the training part, there is another important part that the continual learning method have to deal with, is the handling of varying model size. So first of all, I want to mention that Avalanche is compatible with any PyTorch NN module. And so you can use any PyTorch model into Avalanche. But it also comes with additional modules to handle the specifics of continual learning, which are subclassing the NN modules and are called these dynamic modules. So dynamic modules in continual learning are important because sometimes some methods need to instantiate new parameters when they encounter a new task. And that's why we need them in Avalanche. So while the specifics of like very specific methods are left to implement, like I would say if you really need to instantiate, for instance, a new ResNet block at whenever a new task comes in, then you can implement it through these dynamic modules, and inside of the templates they will be automatically expanded as the algorithm go. But most methods do not really need to do this kind of thing. So in Avalanche, it comes with very useful, just basic dynamic modules that are almost always used, which are the incremental classifier, which is basically an expandable layer for the class incremental learning setting. So whenever you encounter new classes, it will increase the size of the representation of the logits for this layer. And we also have it for the task incremental learning setting. So this multi-head classifier that comes also with a multitask module, which is basically just changing the forward pass so that it accepts task IDs. Okay, so just for a quick demo of how these models, the dynamic models work, we have here just the definition of multi-layer perceptron. Hope that I just noticed an error, but it's okay. So basically, once you know the layer, the classifier, the name of your final layer, then you can change it by, you can replace it by one of the existing layers in Avalanche, like in that case, incremental classifier. And the good thing is that you don't have to know the number of classes in advance. For instance, here you see I instantiate the multi-layer perceptron with one class. But it's okay because I'm not supposed to know how many classes I'm going to see in the future, and the Avalanche is going to handle that. So I just replace this classifier by an incremental classifier, and then I can start training. And for the multitask scenario, it's the same. We have a utility function that does the same thing with the multi-head classifier, but also turns the model to this multitask module. And yeah, so once these dynamic modules like the incremental classifier are initiated, they can be adapted by calling this adaptation function on top of an experience. But this step, you don't have to worry about it. It will be called automatically, usually in the plugin. It's better to check, of course, if this is working in case you modify the strategy, but it's called automatically whenever encountering new experience. So yeah, that's it for the dynamic modules. But basically, what you have to retain about this is that for the classical ones that we always use, they are implemented in Avalanche. But if you want to implement your own, you have to subclass these dynamic modules. Okay, so now let's jump to the last part of the library, which is the metrics and the logging. I think the most important part to understand about this is that the metrics are also implemented as plugins. And the only difference compared to the training plugins, let's say, is that these plugins of the metrics will most of the time use the callbacks that are called inside of the evaluation loop. Because in the end, evaluation is nothing more than doing forward passes on the evaluation experiences, and then just don't train on it. So don't do any backward pass or any optimizer step. So you just do forward passes and you get whatever output you have, and you can compute any metric based on that. So that's what metrics are using. They are plugins, and they use these callbacks. So there are already a lot of available metrics in Avalanche, like accuracy in terms of experience accuracy, stream accuracy, class-specific accuracy. So a lot of different kinds of accuracies, also incremental accuracy. But also there are some continual learning specific metrics like forgetting, backward transfer, and system usage metric. And also as it comes to the logger, yeah, there are very classical loggers that are already available, like the TensorBoard and 1DB one, and also text CSV logger. But of course, if you need your own logger, you can implement it yourself. It's really not very complicated. And this is how you instantiate the metric. You just use the metrics available, and then you create them. You create the loggers, and then you have to use this evaluation plugin, which is basically sticking together the metrics and the loggers, and is fed to the strategy. Just one quick util that I want to mention, because I think it's really convenient one, is whenever you need to log a new metric or just log some value, sometimes it's better to create a metric plugin. Sometimes if it's just something temporary, or then you can use this evaluation plugin utility function, which is this publish metric value, and which directly publishes whatever metric to and broadcasts it to the loggers, which will log it this value. Okay, so now I will present you just some ways, like some links on how to look for help if you need help when using Avalanche. So we have a website. We also have an API doc and a tutorial. And of course, if you have any question about the library, there's a lot of maintainers that are that can answer your questions on the GitHub discussions. And if you find some bugs, yeah, we will be very grateful that you share them in the issues, so that we are aware of these bugs and fix it as soon as possible. Okay, so now I'm just gonna do a quick demo. That's if you want to code along or to try it, you can go on this repo that I will present in the second part, and I just created a demo file, which is very similarly looking to the minimal example that I showed you before. Basically, I'm going to present you this quickly. So yeah, really, it's almost the same thing than the minimal example that I showed you. So here we instantiate the benchmark. Then we create a model. Then we wait. I'm going to zoom a little bit so that you can see better. Then you create the loggers and the metrics. You stick them together in this evaluation plugin that I have here. And then you create some plugins like the replay plugin. Here I just wanted to combine the replay plugin and LWF plugin to show you kind of how these plugins can be combined together. And then I add this plugin in the same list, and I feed them to the strategy. Okay, so now what I'm gonna do in this demo is just to add another plugin, and I'm gonna show you, for instance, how, like, if I want to. So right now, this parameter for the regularization strength of the LWF plugin is set to 1. But let's say I want to schedule it during the training. No, this is very classical operation that you could want to make. So I'm just gonna show how to create another plugin that is scheduling this value. Okay. So yeah, I will call this plugin like Lambda scheduler, and its role is just to schedule the. Its role is basically just to schedule the value of the parameter of another plugin. And so we're going to create here this scheduler. And as a key, I want to schedule the alpha parameter of this LWF plugin. And let's say we want it to start to 1, and it will increase with a small coefficient because we want to increase the regularization strength. Okay, and then I just need to add this scheduler plugin to the list of plugins. And that's it. Yeah. So now I have to code the actual inside of the plugin, and how I will do that is that I will use this after training experience. So that after training on each mini batch, here we are in an online setting, so one experience equal 1 mini batch. After training each mini batch, I will increase the value of this regularization strength. And so how I do that is that just I add the parameters that this function needs. And then I also need to access the number of training experience that the strategy has seen. And I can access that through this yeah, I can access that through this object. This is the kind of thing that you're going to learn about the library, all of these attributes of the strategy. But for instance, here I'm just what I want to do is just to get the number of training experiences so that I get the correct value for my scheduling. And then what's left is that I set the attribute of this. Okay, and one more thing that we could do is just to check that all this whole scheduling works, is that we could just log the value with the util function that I showed you before, so that we have this nice following of the schedule of this parameter and we don't lose track of it. So I'm just going to do that using strategy evaluator, but publish metric value. And then this need this object that will basically this is an object that holds the metadata of the metric. We are logging the value of the key. And then we need to give some coordinate for the plot. I like to give as coordinates training iterations, but this is up to personal choice. So I will say this does not have to be the same, let's say, coordinates and the one we use for the scheduling. Okay, so now we should be able to run this modified scripts. This works. So we see that we have the list of plugins that I print here. We have the LWF plugin, the replay plugin, and the Lambda scheduler that we added. And so now it's running, and if we log into TensorBoard, we should be able to see the scheduling of this plugin. So I scheduled it as a piecewise linear function, so I wanted it to stay stable in the beginning. Then after the few first iterations, I wanted it to grow. And so we should see this going through. Yeah, it should start to grow now. Yep. So here we see it's growing now, and then it will stop at 3 as I scheduled it. Okay, so yeah, that's it. For the demo, I think. And now I can jump to the next part of the presentation, which will be about the application case. Okay, so in the second part, I want to present you a project that we did using the Avalanche library. And we also released the code repository that I used for the demo for this paper. And basically what we did is a survey using the Avalanche library. So we did a survey in online continual learning, and we released the repo at this URL and the paper at this URL, so feel free to check it out. Okay, so first of all, I will present you quickly the results and the methods that we use in the survey, and then I will present the content of the repo and how to use it. So basically, we can classify the online continual learning methods using this nice scheme that Vincenzo made. And that is basically showing that any continual learning method receives this experience for the train stream and then does some number of training passes. And so here, because we are in online continual learning, we have to think that this is a mini batch. And so we do several training passes on this mini batch, but at the same time, we also have an external memory in the case of replay methods that we can sample from and augment. And then we just learn with the concatenation of all of this current plus data from the memory. And so from here, we have different methods like mirror, for instance, changes something in the sampling of the memory, while a lot of methods change something in the loss, like ERAs introduce this asymmetric loss that does not treat the replay samples the same as the current samples. And other methods like SCR change both the loss, but also something on the classifier, so on the models part of Avalanche, let's say. For instance, here, SCR uses a nearest classifier mean at inference time. Okay. So now a bit more about the setting and then the results. So this is online learning. Mini batch size is very small, let's say. It's not the ideal online learning that we would like to have with mini batch size of 1, but it's very hard in deep learning to do that. And we just stick to the main setting that a lot of the the method we compare to used. And so this mini batch size is of 10. We use this slim ResNet 18, which is slim version of ResNet 18 that is used a lot in online learning for its reduced number of parameters. And then I think the biggest specificity of this survey compared to previous ones is that it's using Avalanche, and also that it has a lot of metrics that were not reported necessarily in previous surveys. Like, of course, we present the accuracy, but also which shows voluntarily to drop the classical forgetting that is used in a lot of class incremental learning work, but that we think is not really adapted as it is used. Like, because this forgetting was initially developed for, let's say, task incremental learning and then ported to class incremental learning. But in class incremental learning, it's very different because the difficulty of the problem that you have to solve evolves, because as the number of class grows, it's harder and harder to, for instance, it's harder to distinguish one class between 100 than distinguishing one class between 5, which is usually what you have in the first task. So that's why we think the classical forgetting is not very relevant to use. But also we added this continual evaluation metrics. And what continual evaluation means is that after learning on every mini batch, we evaluate on the validation datasets. And so, yeah, this can be, let's say, computationally quite intensive, because you have, after every iteration, you have to run this full evaluation pass of the validation. But this is something we did, and that way we can report some metric like the stability metrics introduced in a recent paper, and the average accuracy under the curve also. And yeah. Another kind of metric that we considered here is the representation quality. And this is basically to check that, so this is a kind of metric that usually is used in unsupervised learning, but was also adapted to continual learning by recent works. And so we choose to evaluate this representation quality as well. basically to check whether the problem is the feature extractor or the classifier, because we know that in classical motor learning, the problem is oftentimes the classifier. Okay, and so now just for a few details, it's possible for each mini batch to do many iterations on it, as long as once you have trained on it, you throw it away and you don't use it anymore. So we used in this survey like 3 iterations for SpeedCipher 100 and 9 iterations for tiny ImageNet. And also we use augmentation in both the current data and the buffer data. So yeah, that's it. Now a quick talk about the results. Yeah, I think mainly our conclusion were that, as you can see, there's no method that we saw that is really dominant across the board. Like some methods have better results in some metrics, but have worse results in other metrics. And another shocking thing is, let's say, the prompt accuracy for most of the replay method is quite close, or even in that case, it's even bigger than the one for the IID stream, which honestly is quite surprising and means that maybe in online learning at least the main problem is the learning of the classifier, and we should be more careful about this kind of metric. Okay, so now I will present you more the technical part of this repo and the fact that it uses Avalanche and that it's it can be a very nice starting point to launch your experiments that use Avalanche. Yeah, I think so quickly about the tech stack. So we use Avalanche for everything that is revolved around continual learning. But then we also include the use of 2 different libraries, which are Hydra. And Hydra is a library, just to quickly present it, that enables you to have this modular configuration file management, and it makes it very easy to have a lot of different configurations without having a lot of different configuration files. Like as the number of potential configuration file scales, Hydra will make it a lot less. And also it provides a very easy to use command line tool that I think is nice for reducing the errors, because it's very easy to introduce an error whenever you enter a parameter inside the command line, which with Hydra it will happen way less. And also we use parallel computing in 2 occasions in this library. So one of them is for the hyperparameter tuning. So in order to fairly compare these methods, we run hyperparameter tuning on each of them so that they can have their, not their ideal parameter, but something closer to the ideal. And the fact that they all use this same hyperparameter tuning process makes it that it's a fair comparison, as fair as possible. And then also we run this continual evaluation that can be quite intensive in parallel, so that it's taking less time. Okay, so now a quick thing about Hydra and how it's organized inside the repo. So if you notice inside the repo, there is a directory which is configuration directory. And inside of it, there's a lot of other directories.
I'm so sorry to interrupt. You have 5 minutes.
Okay.
Little less than 5.
And yeah, basically you have a lot of, so I think the important thing from this slide to retain is that even though you have a lot of directories inside of this, it's not very important to care about all of this, because only 3 useful directories are to retain. But basically what you have to understand is that these directories all contain different configuration files. So for instance, the optimizer directory contains 2 different configuration, one for each optimizer, and just to switch between one of the 2, you just have to change this in the command line. And overall, you can just start an experiment by just running this command and selecting the experiment and the strategy, and yeah, that's it. So yeah, here is just some resume. If you want to add your method, you just have to instantiate it in the method factory. Then you create a configuration file with your the argument specific to your methods, and then you can run it just the way the other methods are run, and that way you can very easily compare to other methods. Okay, I think I will do that. Okay, and other thing that I'm going to explain to you know is how to run this hyperparameter tuning that I talked about, because I think it's also important. And so basically for hyperparameter selection, we use the method that is used by previous works. It's not ideal because it's not, we cannot say it's a correct hyperparameter procedure, tuning procedure, but the thing is that in online learning, it's very hard to perform a correct hyperparameter selection, because you, unlike normal continual learning, you don't even have access to the whole data of the current task. And so you cannot say, okay, I will take 5% of the data of the current task and do my hyperparameter tuning in it. So yeah, we have to use a method that is not correct, but is used by other work. It's just to select first 20% of the stream, and then we train on this 20% of the stream, and we evaluate on the validation stream, which is 5% of the data that is saved, and then we select the hyperparameters based on that. And so to do that in the repo, you just have to add the search space of your method to spaces.py, and then you can launch the hyperparameter selection with this main HP tuning and the same syntax than for the main experiments. Yeah, that's it. If you have any question, feel free to ask.
Great. Thanks, Albin, for the presentation. Just in time. I believe we have time for one question, and if you don't mind, because I believe that we have like 5 questions in the Q&A.
Okay.
I believe we have time, so you can answer one question, and the rest you can answer offline if that's okay with you.
Okay.
So let's start with the first one. So Jose asked, it is possible to implement Avalanche in a problem in which the original dataset has 3 channels, but the new data collect has less channels, or more than 3 channels?
What do you mean by a channel? Do you mean by...
I believe he's asking about if it's easy to change, for example, the model, so we can use data with different kind of channels, not just images.
Yeah, okay. Like instead of 3 channels, we have more. Okay. Yeah, of course. I mean, let's say the Avalanche library is quite not regarding on the kind of model that you fit to it, as long as it's a torch model. And I believe torch is really well made so that you can deal with this kind of situation. So yes, of course, I think it can be used in that case.